I'm Marty Grusho. This is a hydrogen inflation safety system that we've installed in Sterling, Virginia.
The system components shown in this video were installed in the Upper Air Inflation Building at the Weather Forecast Office in Sterling, Virginia. While the position of the equipment at other sites that have undergone conversion may vary, the form and function of the equipment and the operating steps are the same.
This is a safety system that's intended to make it safe to put hydrogen into a weather balloon. The table is essentially pretty much standard weather service table. The fill valve is, buoyancy valve is the same as it has been for the weather service. There's a few valves that are added. The main point is that this operates exactly the same way that it does. We didn't change it. It's the same as it for the weather service. Buoyancy valve, fill valve that turns on and off via the balloon. So I think that's a pretty simple system. We did add a gauge at the fill valve and then another isolation valve here. Another important improvement for converting to hydrogen is that every place there's hydrogen, it's in stainless steel tubing, which is pretty small diameter tubing, which is a safety feature in that first it's robust, it doesn't fail in the event of a fire. Second, it has a small internal diameter, so it kind of limits the flow rate in case of a bad leak. This system has the capability to fill with either helium or hydrogen. That's accomplished via this, which is a three-way valve. So if you can see this is in the hydrogen position now. It's a three-way valve. The center position is off. This position is to the helium. And so that would be all that you would need to do if you wanted to change from helium to the hydrogen fill. Normally, this valve could be left in the hydrogen position. So this is the controller for the safety system. The operating steps are first to hit the reset button, the black one. What that does is it clears any memories or troubles that might have been in the system from the previous launch. And then to push the standby button. What the standby button does is it boots the system, brings it to life, and turns on the exhaust fans, the two powered exhaust fans that are at the ceiling level. Connect the balloon. When you're filling a balloon, once you hit the standby button and you've got the balloon connected, the next thing to do is to turn the gas supply on, which is done outside.
One of the key safety features of the hydrogen safety system is the outdoor storage of the gas. Any significant leaks of hydrogen will occur outside of the building and dissipate quickly into the atmosphere. The emergency shutoff valve is a well-labeled indicating valve located outside of the building. Hydrogen flow is off when perpendicular to the hydrogen line. Hydrogen can flow when the shutoff valve is parallel or in line with the tubing. The valve is a 90-degree valve that does allow for partial opening. It is important that the valve is either fully open for filling purposes or fully closed when the system is not in use. To allow hydrogen to flow, to complete a fill, the operator must go outside and turn the valve to the on position. Also located outside is the gas regulator, which steps down the high-pressure hydrogen contained in the cylinders to a pressure of approximately 23 pounds per square inch at the regulator. This allows gas flowing at the nozzle to be released at approximately 15 psi due to friction loss in the tubing. The solenoid valve is also located inside the regulator box. This valve is automatically controlled by the system located inside the building to allow hydrogen to flow through to the balloon.
This is the system. This is the standard weather service hydrogen control valve. This is the power, provides the power for the solenoid valve inside at the fill valve. This is standard weather service box. Nothing that we do in this conversion changes this, and you still need it. But it operates the same as it always has, which is the only thing that an operator needs to do to fill a balloon is flip this switch to the on position, and then the red light comes on, showing that it's energized. Okay, once the hydrogen is on outside, we've got gas to the system. Once the hydrogen system is turned on, the weather service system, now we've got gas pressure all the way to the fill valve, and it needs to be on to allow gas to flow to the balloon. So now we're set, we've got our balloon on the table, we're ready to flow gas. The system will not flow gas until we hit the run button. What the run button does, is it opens the solenoid valve outside. Press this button, there's about a 5-second delay, and then the solenoid valve opens and allows gas to start flowing into the system. So now if we had a balloon connected, gas would be flowing.
The standard installation for outdoor hydrogen storage has the capacity for 2 sets of 6 interconnected cylinders each, also referred to as 6-packs, of compressed hydrogen on the A side supply and 2 additional 6-packs on the B side. If the gas should stop flowing entirely during a fill, the likely culprit would be that one of the supplies was depleted. The operator would then have to go outside to the supply and turn the 3-way supply selector switch from the current side to the other, for example, from A to B. The system allows for the switching to occur. The mass flow counter provided as excess flow control would only count actual flowed hydrogen. The gas supplies are provided with high pressure gauges at the top of the storage cage to indicate how many pounds per square inch are remaining in each supply.
We wanted to go over some emergency procedures. The first thing is that the system has some automatic emergency features built into it. The first one is a fill timer, so that it never takes longer than 30 minutes to complete a fill. The system will automatically shut off. The second one, we talked about that the ventilation fans are not operating correctly. The system will automatically shut off. And the third one is if we've ever flowed too much hydrogen, like more than 95 cubic feet of hydrogen, the system will automatically shut off. So those are the built-in features. And then there's some emergency procedures here related to hydrogen fires. So the first thing about hydrogen fires, if we have a hydrogen fire, we want to exit the building. We don't want to do anything other than that first, because now we have the capability to isolate the hydrogen gas supply outside the building from a safe location. And then, so we do that, isolate the hydrogen shutoff valve, call 911, notify the meteorologist, and don't try to put out the fire. With a gas fire, a gas-fed fire, it's not always the safest thing to do is to put out the source of the gas, because now we have unignited gas being released into the room, which can create a worse condition. So the best thing to do is to isolate the flow of the gas, which we can now do from outside the building. For a hydrogen balloon rupture, again, exit the building and close the emergency gas valve outside the building. That's very easy and fast to do. And then I would just let the system run, let the ventilation system run for 10 or 15 minutes, and then come in and discard that balloon and get another one. So one of the capabilities of this system is that it can inflate a balloon with either helium or hydrogen. We talked about this 3-way valve. So this valve can be changed to the position right now. It's indicating towards the hydrogen direction, and now it's indicated towards the helium direction. So if we had a reason for inflating with helium, it would be as simple as flipping this switch, which allows, these are helium bottles, the now wall-mounted regulator to be connected, and it basically is the same as the Weather Service is used to as far as using helium. The main point being that all we need to do to switch is change the position of that 3-way valve. The wall-mounted regulator is a good feature because it gets the regulator in a stationary position, and when we change from cylinder to cylinder, we no longer have to make and break this connection. We use, this is a convoluted high-pressure tubing rated for 38,000 psi, and this is a connection that can be loosened with the 1 1/8 inch wrench. And it's much lighter and easier to handle than the entire regulator. So I expect that using this convoluted tubing will be a plus for the Weather Service because it will increase the longevity of the regulators.